Welcome to the itdvds.com YouTube channel. This is just a sample of the training available at itdvds.com. If you would like to see complete training, please go to itdvds.com. Now let's begin the sample. This is a cluster diagram of a cluster we're actually going to be creating. Now first let's talk about how a cluster works. Basically we have nodes in a cluster, and in this example we have two nodes, cluster 01A, cluster 01B. And then we have shared storage, which is going to be an iSCSI SAN or a fiber channel SAN or some kind of serial attached SCSI device. And we're also going to have a public network and a private network. Our public network is how our other servers or other users are going to access the cluster, and a private network is going to be used for communication between the nodes to make sure each node is up. Now on each node, these are just servers. They have disks inside them. We're going to install Windows Server 2008 R2 Enterprise. So cluster 01A is going to have Windows 2008 R2 Enterprise, and same with cluster 01B. It's going to have Windows 2008 R2 Enterprise installed on disks internal to the server. So those are not shared disks. And we'll also be installing the clustered application. And that can be a file server, a SQL server, we can cluster SQL server, or things like IIS. Whatever the application is we're trying to cluster, that will be installed also on each node. And this is just going to be the executables used to run that application. Any data that's specific to the application will be stored on our shared storage. For example, let's take a file server. When we cluster a file server, we're going to install the file server role on cluster 01A. We're also going to install the file server role on cluster 01B. But the data, the actual shared folder, and the files within the shared folders are going to live on our shared storage. This way, both nodes have access to that shared storage. And the application, which in this case is the file server, can only be active on one node at a time. So let's say it's active on cluster 01A. Well, when our users go to access a file share that will be clustered, they're going to access it with a clustered name. And in our case, it's going to be cluster 01, and each application can have its own clustered name. We'll see that, but for simplicity's sake, it's going to be cluster 01, and that cluster name is going to translate to a clustered IP. In this case, it's 192.168.6.50. And these are virtual names and virtual IPs. So that means they can be owned by either cluster 01A or cluster 01B. So our clients are not going to directly access a specific node. They're going to access a clustered name, which will translate to a clustered IP. And if cluster 01 is the active node, it will own that name and IP. So when this client tries to access a share on cluster 01, it will automatically be routed to cluster 01A. Now let's say we fail over to cluster 01B. So cluster 01A becomes the passive node and cluster 01B becomes the active node. Automatically, without any intervention, any traffic now going to cluster 01, any share, will be routed to cluster 01B. So that's the advantage. And because each node has access to the shared storage, there's no data loss when that happens. So let's say on cluster 01A, our shared storage is the G drive. When we fail over to cluster 01B, cluster 01B is now going to own that G drive, and it will become active. And all the data is the same because it's the same spot on the disk. We're not copying data or anything like that. It's the same data on the disk. So now let's talk about each network. The first network is the public network, and this is the network that our other servers or our clients are going to use to access the cluster. So in the example of a file server, the user is going to go to / cluster01 / and then a share name. And that is going to be accessed via the public network and will be automatically routed to whichever node is active. The next network is the private network, and this is just used for internal communication between nodes to make sure each node is up. It's kind of like a health check. Cluster 01B is asking cluster 01A, are you up? And vice versa, to make sure there isn't a failure, because in a cluster, if there's a failure of a particular server, an automatic failover will automatically be initiated and another node in your cluster will take over automatically. That's the real advantage. And the third network is going to be either an iSCSI or fiber channel network. If it's an iSCSI network, this is going to be an Ethernet network. And by the way, both the private network and public network are Ethernet as well. And sometimes in a two-node cluster for the private network, we just use a crossover cable that directly connects your cluster 01A to your cluster 01B, so that completely eliminates a need for a switch. But if you have more nodes than two, you're going to need a switch to connect all your nodes to for your private network. But it is an Ethernet switch. So again, down here, if this is an iSCSI SAN, and a SAN is just a storage area network, which is basically normally a bunch of disks and a storage processor that handles how the disks are configured, how the LUNs are configured, and we'll talk about that in a second, and also what servers have access to which LUNs. So if this is your iSCSI network, it's going to be Ethernet as well. So just like your public network and private network, but ideally you really want a separate network for your iSCSI network. You don't want to mix it with your public network. So you wouldn't want to connect it to the same switch if possible, because you don't want a situation where, let's say, you're copying a large file or something like that where a lot of bandwidth is being used up on the connection to this public network switch. But if it's also being used to connect to your iSCSI drives, then your iSCSI drives are going to be bogged down because you're using up all that bandwidth. So you want to separate. And we're going to see this, the iSCSI network. And if you're wondering how it looks, it basically shows up, let's say we have a LUN, a 200 gig LUN. And a LUN you can think of as just a carved out piece of data, or a piece of storage. So let's say this iSCSI SAN has 10 disks in it, and that we do a RAID 5 across these 10 disks. That gives us 2 terabytes of space. Well, we don't have to take that whole 2 terabytes and assign it to one server or another server. We can carve out a LUN, which is like a, let's say, 200 gig LUN, and assign it to a specific server that's part of our iSCSI network. So that's really the advantage. We're taking a lot of disks and carving out individual space or LUNs for individual servers. In our case, for our cluster, let's say it's a 200 gig LUN, we want to assign it to all of our nodes in our cluster, because all the nodes in our cluster need to be able to see the shared storage. And this can also be a fiber channel network. In that case, we would have a fiber channel SAN, and your servers would be connected to a fiber switch with a fiber cable, which is just a thin orange fiber cable normally. And the fiber switch is zoned so that your nodes have access to the SAN, and then on the SAN is where you normally create things like your RAID group and your storage group, which tell the servers basically which LUNs they have access to. And the storage really is the key to a cluster. I hesitate to call it a single point of failure, but if you lose your storage, let's say you've got a clustered SQL server here and your databases are going to be on your shared storage. If you lose that, then you lose your cluster. Your cluster can no longer function because that's where the data lived. Now in a cluster, you can lose a node, you can lose this server, and that's fine because this server will take over and it can see the shared storage. But your shared storage is the key, and that's why in an enterprise environment, normally we have a very, very robust SAN as our storage. And a SAN is normally inherently redundant. We have RAID, so if we lose a disk, we're okay. We have multiple drive shelves, so possibly if we lose a whole drive shelf, we're okay. We have multiple power supplies on our SAN. If we lose power to one side, we're okay. So normally, pretty much everything's redundant in a SAN, and that's why you want to be careful if you're going to use a little bit cheaper storage. iSCSI is making it more easy to use, cheaper storage that might be a little less redundant, but we're going to be talking about that in a little bit and why we want to be careful about doing that.